Hi and welcome to Space with Sarah. This week we're doing something a little different. I'm going to go through and answer some of the great questions that you've been posting so far on the first videos. I also want to take the chance to just thank you all so much for engaging and asking these great questions every week. It really helps me and the audience, I think, in both thinking about new topics to discuss and just learning more about space in general. The first question is from Kasia, who's wondering if the universe will expand forever. And we're actually doing a Space with Sarah episode on this very topic, so you have to stay tuned for that. But in short, within our current paradigm of cosmology, we actually have a few different solutions to what could happen to the universe. But all observations so far indicate that the universe will expand forever, and that this will actually happen faster and faster as more time passes. Giovanni wants to know if the smaller galaxies that we're finding around Andromeda and the Milky Way could make up what dark matter is. And I actually just did a collaboration video with Fraser Cain on the topic of dark matter galaxies, so check that out. The answer is definitely yes, there are clumps of dark matter, kind of like dark matter galaxies, orbiting other galaxies. But these can't make up for all the dark matter in the universe. This next question is from Rajiv. And the way I understand your question is that you're asking how a star can be stable if it's made up of a plasma of charged particles that should be repelling each other. And the answer is that all of these charged particles in bulk actually cancel each other out, while the gravity of the whole star is made up of each single mass of each particle. And then of course you do need to have the stabilizing force of the pressure outwards from both fusion and from particles moving around in the star. Kiki wants to know which is the bigger galaxy, Andromeda or the Milky Way. And this isn't actually a trivial question. There's been a lot of debate throughout the years of which galaxy is more massive. And the latest research that I've read states that Andromeda is probably slightly more massive than our own Milky Way. But they're both roughly 1,000 billion times the mass of our own sun. And even more interestingly, Andromeda and the Milky Way are not the most massive galaxies we know of in the universe. So they're also so-called elliptical galaxies, and these can be more than 1,000 times more massive than our own galaxy. This next question is from Rajiv. Again, thank you so much for all your questions. In this one, you're asking how we can fuse elements heavier than iron when I just told you that you don't actually gain energy from fusing those elements. So what needs to happen is you need to have something called the R process, which is rapid neutron capture. And that can happen, for example, in a neutron star that merges with another neutron star, or in one of these supernova explosions. And what goes on is that you have a nucleus being bombarded with neutrons, and these neutrons can then decay into a proton while they're absorbed in that nucleus. So a lot needs to happen, but this is how we can build up heavier and heavier elements. This last question is from Jan Albert, who wants to know if it's been ruled out that neutrinos could be what makes up dark matter. And we actually now have upper limits of the mass of neutrinos. We don't actually know the individual mass of each neutrino, but we do know the total mass that they have all together. And it turns out that this can't make up for all the dark matter that's out there. So while they might be adding to whatever dark matter makes up of the mass in the universe, it can't be the full solution. Thank you so much for all your questions and comments so far on the videos. It really means a lot to me. Keep in mind that as you're commenting and posting, I also get inspired for new material, so please keep it up. And thank you so much for watching. To actually get the content out. Blah! Over the expansion of space on scales like, sorry, did we do the slid thing? Did we slide and roll and everything? This is so not relaxed. More people on here. Nailed it. Dark matter. So sorry. Hopefully this will be resolved within our lifetime. Because you might die before. Oh, we're still rolling. Thanks for watching Space. Bye.